We're going to cover 7.5 and 7.6. Today, use sine, cosine, and tangent ratios to solve right triangles. Trigonometry is the study of relationships between sides and angles of triangles. So if I have an angle A, then we refer to this side over here across from A as the opposite side. We refer to the side that touches A as the adjacent side. This is the adjacent side. Now, I don't call this an adjacent side because it's across from the 90. The one across from the 90 is called the hypotenuse. All right? So opposite A we refer to as the opposite side. Touching A but not across from the 90 is the adjacent side. And across from the 90 is the hypotenuse. There's relationships that we can define based on labeling the sides of the triangle like this. Trig ratio is a ratio of the lengths of two sides in a right triangle. So the ratio, if we do the sine of angle A, the sine of angle A is going to be the opposite over the hypotenuse. That the value of the opposite side, the length of the opposite side over the length of the hypotenuse. That's the sine of angle A. Opposite over hypotenuse. The cosine of angle A is the adjacent side over the hypotenuse. Adjacent side over the hypotenuse. And the tangent of angle A is the opposite side over the adjacent side. So these are going to be numbers because they're lengths of those sides. It's talking about the length of the opposite side over the length of the adjacent side when it says opposite side over adjacent side. Now, to help you remember which ratio goes with which trig function, there's a saying we can use. SOHCAHTOA. So memorize SOHCAHTOA, and that tells you, can help you remember what ratios go with which trig function. The SO stands for sine is opposite side over hypotenuse. The CA is cosine is adjacent over hypotenuse. And the TOA is tangent is opposite side over adjacent side. So write that somewhere. You can write, and then you could write that at the top of your quiz, your test, or whatever. When you get it, and then you can refer to that to help you remember which ratios go with which trig function. Everybody have all this? Okay, moving on. So we're going to do the sine of C, right? So sine of C would be, okay, it's SO, S-O-H, sine is opposite over hypotenuse. So it's P over R. Cosine is adjacent over hypotenuse, T over R. T is adjacent to angle C over the hypotenuse, so it would be T over R. Tangent, TOA, opposite over adjacent. P is opposite C, T is adjacent. P over T would be the tangent. Kayla, your milkshake's in the trash because you're not supposed to bring that in here. I hope that's not why you were late. All right, let's do A. Somebody tell me, what would the cosine of A be? Cosine of A. Okay, cosine of, yeah, go ahead, Ken.
T over P.
Okay. Say again.
Would it be T over P?
That would be the sine. Cosine is adjacent. Ca, C-A-H, adjacent. And it's over the hypotenuse, R. So it'd be P over R. Not P over T, P over R. What about sine? Somebody think they know what sine is in this picture? Okay, sine, it's the SOH, right? Sine is opposite over hypotenuse. So we find A, we find the opposite side. The opposite side is T, the hypotenuse is R, so it's T over R. And then the tan of A, that's your TOA. Can anybody tell me what the tan of A would be? All right, so here's A. We look for the opposite and the adjacent. T over P. Tan of A is T over P. All right. Any questions? Okay, you just have to memorize those relationships. You'll never find the sine of the 90-degree angle. Okay, a B. So if you're doing that, you're doing something wrong. We don't do the sine, cosine, and tangent of the 90. It's of the other two. All right, the angles have to be less than 90 to do the trig functions on them. Notice that one of the reasons why this is set up like this is you'll notice that the sine of C is the same as the cosine of A. The cosine of C is the same as the sine of A, and the only thing is the tangent of C is the inverse of the tangent of A. Some examples. All right. We're going to look at the diagrams at the right to find the trig ratio. Let's take another shot at this. Can somebody tell me the sine of A? Sine of angle A. So here's angle A. Let's write the saying up here at the top. So, TOA. Right? SOHCAHTOA. Sine of A, what would it be? Okay, we're going to look for the opposite. The opposite of A is A, and the hypotenuse is C. It'd be A over C. Cosine of A. Eric, what's the cosine of A?
B over C.
Good, it's B over C. Adjacent over hypotenuse. It would be B over C. Tangent of B. What's the tangent of B? Aaron. B over A. It's the opposite. Here's B. It's the opposite over the adjacent. So it's B over A. The sine of J. Sine of J equals what, Abby?
BC.
It's in a different triangle. Here's J.
Cosine.
We're doing the sine of J.
So
So sine is opposite over hypotenuse.
A over L.
Okay, here's J. What's the opposite of J?
Okay.
No, that's next to J. That's adjacent. J over hypotenuse.
L.
J over L. Good. So that's J over L. Cosine of K. Kennedy.
Okay. Jason. Would it be J over
The hypotenuse.
which is L?
Yeah, J over L. Cosine of K equals J over L. All right, and then finally the tangent of K. Tangent of K. What do you think, Gunnar?
L over J.
Let's see. It's the tangent is the opposite over adjacent. So we look for K is here. The opposite is K. The adjacent is J. So it'd be K over J. All right. Questions? Okay. So through repetition, you will learn these ratios, and you'll learn how. It's memorization of what goes where. Now we'll apply this to some examples here. Find the value to the nearest tenth. Okay. So we've got x. Okay. Is what we have to find. Here's the angle. 17 is opposite of 59. X is adjacent. Which trig function does that involve? Opposite and adjacent. Tan. So we would do tan. We do tan of 59 degrees is equal to the opposite 17 over the adjacent x. We've got to find x. So first I've got some algebra to do, but I can tell you whenever you have a value, something here and an x here, you can just switch their places. We could solve it algebraically. It'd take several steps, but I can just tell you these just switch if you have to find x. So we can say x equals 17 over the tan of 59 degrees. Right? Now, get out your calculators. On your calculator, there is a sine, cosine, and tan button. Most of you have scientific calculators. So on a scientific calculator, okay, it's going to be, what you're going to do is you're going to enter 17, to find x, you'd enter 17 divided by, and then you have to enter the number first. Well, let me see. It depends on the calculator. This is like a TI 30. You do tan, and if it puts tan on the screen, then you enter 30. Oh no, 59. 59. Enter. Okay, you should get 10.214. We're going to take these out to 3 decimal places. X equals 10.214. Now if the tan doesn't show up on a graphing calculator, you can enter it that way too. Just the number divided by, hit tan and then the number. Let me see about this one here. Yeah, that one works. Let me look at your calculators. Looks like everybody, yeah. You what?
Wait, how do you?
Okay, yeah, now if you have a graphing calculator, your mode has to be set to degrees. Where the default is radians. So check your mode, hit mode, and then did you get it that time? Yeah. So change your mode, hit mode, and then it's what, fourth one down or something?
Yeah, fourth one.
Fourth one down. Go down and then highlight degrees, hit enter. Anytime I clear your calculator, it'll automatically go back to radians. So go back in and reset it to degrees. Was there anybody not able to get 10.214? Okay, so we do 17 divided by, where's your 10? It's not, oh, it's calculated. Yeah, you don't have trig functions on this calculator, I don't think. Let's see. Let's try this. Second trig. Okay, so then you got to hit second trig, and you're going to do tan. So that would enter tan, and then you type in 59 parentheses. Enter.
Okay.
All right. So you got to use that second trig function and then select the function. All right, everybody have it? Let's look at another example. So number 2. Degrees is our angle. Which trig function would this involve?
Sin or sin.
We don't know anything about the hypotenuse. To do cosine or sine, you have to do the hypotenuse. This would be tan as well. So we'd have the tan of 26 degrees equals what? What's going to equal? 7 over x or x over 7? Opposite, TOA. Opposite over adjacent. Which one's opposite? Kaylee? 7. So it'd be 7 over x. Now we can switch the x and the 20, tan 26, so it becomes x equals 7 divided by tan of 26. Tan of 26. Right? So do that on your calculator. Do that on your calculator. Tell me what you get. You should get x equals 14.352. Questions on that? Anybody not able to get that? I'll look at your calculator if you need help. Everybody's got it. Okay. Here's an example. Find the length of the hypotenuse of a right triangle if an acute angle measures 20 degrees and the side opposite of the angle measures 410. All right, so we have to draw a picture. Draw a right triangle. There's the right triangle. We have to find the length of the hypotenuse. So that would become x. The hypotenuse would be x. If an acute angle measures 20 degrees, so let's make this the acute angle, we'll make that 20 degrees, And the side opposite the angle measures 410. Side opposite of 20 degrees is 410. Which trig function am I going to use to solve for x? Logan? Yes, very good. We know the opposite and the hypotenuse. So it becomes sine, abbreviated sin, sine of 20 degrees is equal to the opposite 410 over the hypotenuse x. Solve for x, we got to switch the sine 20 and x. Becomes x equals 40 divided by the sine of 20 degrees. Go ahead and calculate the value for me. Calculate the value on that. You have a calculator?
Yeah.
Okay, you should get it out then. What'd you get, Abby?
No, I have a question. How'd you get 40?
Oh, 410. Yeah, 410, sorry. 410. What'd you get for x? Somebody give me your answer. Hey, what'd you get, Aaron? 1,198.76. 76 what? 759. Yeah, with trig, we'll go out to 3 decimal places. 759. Who else got that? Okay, we'll go with that as the answer. Questions? All right. All right, they rounded the nearest foot, so just depends on what I tell you to round to. Okay. Problem solving with right triangles. Okay, so this is angle of elevation, angle of depression. An angle of depression of an object lower than the viewer's eye is the angle with its vertex at the viewer's eye, one side horizontal, and the viewer's line of sight to the object as the other side. So it's going to look like this. This would be an angle of depression. Right? This angle right here is your angle of depression. Come on. This angle is your angle of depression. The angle of depression, or you could have an angle of elevation. An angle of elevation would be going up. Now, the key thing to remember, so you don't get confused when you label the sides given to you on this, the angle of depression will always, one of its sides will always be the horizontal line. Right? Why I tell you that is, you may have a story problem and they tell you there's an angle of elevation. Don't put this angle as your angle of elevation or angle of depression. It's the one made with the horizontal line that's not the right angle. So here's the angle of depression. Angle of elevation would have to be this angle. It's made with the horizontal line. So that's key. Remember that. Here's an angle of depression problem. You're skiing on a mountain with an altitude of 1,200 meters. The angle of depression is 21. How far did you ski down the mountain? That would be, this distance would be x. The hypotenuse would be x. Which trig function do I use? Okay, so you find the 21 degrees. 21 is here. The 1200 is that opposite or adjacent 21? Gage, is it opposite or adjacent?
Adjacent.
Adjacent means it's touching, it's next to. This would be adjacent, it's opposite. Here's 21, this is opposite. This is the hypotenuse. Which trig function uses opposite and a hypotenuse? SOHCAHTOA. Yes. Sine. Okay, so we do sine of 21 is equal to 1200 over x. Right? We have to solve for x, so we switch the place. It becomes x equals 1200 over the sine of 21 degrees. So x equals what? What do you get? What value do you get? Hurry. Let's go quickly. Yes. 3,126. 0.107. We'll go with that. Meters. All right. So there's the work. See if I have any more examples. So there's angle of elevation. It's just the opposite. I talked about it. Okay. So you've got an example of angle of elevation. You can watch this until the bell. So the angle of elevation from a sailboat to the top of a 121-foot lighthouse on the shore measures 16 degrees. Yeah, see you next time. So we would have here's the boat. Angle of elevation from a sailboat to the top of a 121-foot lighthouse measures 16 degrees. What's that?
I was just watching.
Oh. Has find the to the nearest shore, how far is the sailboat to the shore? It's x. Okay, so we would have this would be a tan function. The tan, because we have opposite and adjacent, so it'd be tan of 16 degrees is equal to opposite 121 over x. So when we solve, so that's going to be x equals 121 over the tan of 16. Okay, we calculate that value, and we're going to get x equals 422 feet. That's it for 7.4 and 7.5.